Hello, this video is looking at some of the questions for the modulus function and solving modulus problems. So I'm just going to do some of the questions from exercise 2a, 2c and 2e. So first set of questions on exercise 2a, I'm just looking at questions 8, 12 and 13. So in question 8, it says solve this. So modulus of 3x minus 5 equals 11 minus x. Best way to do any of these questions really is to sketch them. So I'm going to look at sketching these two things right here. So if I want to sketch modulus of 3x minus 5, I need to first think about what does 3x minus 5 look like. So that would be a straight line with a gradient of 3, so fairly steep, and it's going to cross through minus 5. So if I want the modulus of that, what's going to happen is it's going to come down and it's going to ping back up here, reflecting off, or bouncing off the x-axis. And if it's going to be a reflection in the x-axis, this point will be 5. So I no longer want this line, it's going to look like this. So I also want to draw 11 minus x. So 11 minus x is going to cut through up at 11. It's a straight line with a gradient of minus 1. So that's going to be less steep than our modulus function because it's got a gradient of minus 1 as opposed to minus 3. So it's going to sort of come down like this, oops, and it will actually cross, oops, sorry, a bit messy. It will cross this line up here and give me a solution here. And it will cross this line here as well. So we're going to get two solutions from this. If I start with the one on the right first, because that's a bit straightforward, this line here is going to be the positive version of our modulus function. So that's going to come from 3x minus 5. And when that's equal to 11 minus x. So that's how I'm going to find this first solution. So quite simply, I'll rearrange that. So I get 4x equals 16, so x equals 4. So that's the first solution. The one on the left is going to come from the negative version of the modulus function. So all I need to do is put a minus sign in front of the 3x minus 5 and put that equal to 11 minus x. So just a little bit of rearranging will give me the solution on the left. So why don't I take the 11 over? Right, so I'll end up with 2x is minus 6, so x is minus 3. So it makes sense that the one on the left is a negative x value and the one on the right is a positive x value. So those are the solutions. Question 12 is slightly different because it's solving an inequality. So our answer should also be an inequality. So very quickly going to sketch it. And so, well, if I sketch 2x plus 9, that's going to cross the y-axis at 9. And then it's going to, I'm going to bring that down a bit. And it's going to have a gradient of 2, so again fairly steep. Again, because it's modulus, it's going to bounce off the x-axis and look like this, so a V shape. So that's what we want. If I sketch 14 minus x, that's going to come up at 14. It's going to have a gradient of minus 1, so a bit less steep than the other graph. So it will cross at this point here. It's also going to cross at this point here. So those would be our two solutions to the equation, but this is an inequality. It's saying when is the modulus function smaller than the 14 minus x, and that's where it is below it. So it's going to be, if I just highlight that in a different colour, this bit. So that's the bit that we want. So in order to solve the inequality, we need to find these two solutions first, like we did before, and then we can just represent it as an inequality. So again, on the left, I can just put a minus sign in front of the whole thing. And on the right, I'll just take the positive version of it. I'm going to solve these two very quickly and find the two solutions. So I will get something like this. So I'll get x is minus 23 on the left, and then on the right, if I just rearrange this, I will get x is 5/3. So those are my two solutions. The blue bit of this graph is the solution to the inequality. So it's any value between these two things. So that is my solution to the inequality. Last question. I'm going to do this in a slightly different way, question 13, because I kind of solve this by doing B first and then A. You could probably do it a different way, but this is the way I like to do it. So it says that this equation has exactly one solution, and therefore find the value of k for that and state the solution to the equation. So if I draw them, 6 minus x is going to look like that, and if I'm looking at the modulus of that, it's just going to be something like that. It's going to bounce off the x-axis again. Now half x plus k could actually go anywhere, really. So it's got a gradient of a half, so it's less steep than this, and it could actually cross through anywhere on the y-axis. It could go something like that, it could go like that, it could go anywhere, it could also go below. Now where it says it has exactly one solution is where the line is going to cross the V shape just once. Now anywhere below here, like this one here, has no solutions, and anywhere up here has two solutions. The only place where there's one solution is where it touches at this particular point here. So this is where I say I'm going to do part B first. I will say that if there's only one solution, it means it's crossing at that particular point, and that's where it hits the x-axis. In other words, when y equals 0. When y equals 0, I can look at this part here and find out that x must be equal to 6. So I've actually answered part B for you, but we'll kind of get to that in a bit. So that's as if to say 6 minus x equals 0, then x equals 6. So that's part B actually done. For part A, it says find the value of k. So it's basically saying for the graph of a half x plus k, I will sub in y is 0 and x is then 6, and therefore I can work out that k is minus 3. And as I said, we've already done part B. Okay, so that's exercise 2A. I'll do another video for 2C and 2E.